Good morning, guys. So I posted a huge assignment that is 50 questions long. I only want you to do 25 of them, just the evens, and I still think it's going to take you pretty much the better part of this week to work through those, even if you just did 5 problems per day. The fact of the matter is, a lot of these problems that we're going to look at are very, very challenging. They're nothing like if this is how hard the ones we were looking at before are, then this is how hard these ones are. Look, I'm off the screen up here. Okay. They take me a little while to do, as a matter of fact, as well, because there's a lot that goes into them, and it's a really weird method that we have to use, or that we will use, to try to figure these out. You'll see these a lot more in Mr. Malik's Algebra 2 class, and as a matter of fact, some of these challenging problems, like half the ones you're going to see on this worksheet, they wouldn't even be on the keystone. You wouldn't even see them. The keystone tends to keep things very, very straightforward, where that first term, like x squared plus 7x plus 15, whatever it might be, that one's not factorable, I don't think. No, it's not. This first term is always going to be 1 on the keystone. Or if it's not 1, you're going to be able to take out a GCF to make it 1. Or it's going to be one of those special cases that we looked at before, where they're perfect squares, and then you get to, use the double stuffed Oreo or your sum and difference of squares. So the keystone is not going to have these kind of problems. And the thing about these problems is this ain't going to be 1. This might be something like 3, or worse, an even bigger number. And the problem with it is we have to use a completely different method to figure out what's going on. And the method that we're going to use is called factor by grouping. I'm going to try to make it as straightforward as I possibly can. I think there's a lot of value in you being able to at least see these and be able to kind of do them as you move through the rest of your time here in high school, because you're absolutely gonna need it when you get to Algebra 2. So make me proud by showing Mr. Malik when you get there that you kind of know how to do this stuff already, because it puts you a leg up on the rest of the other people who don't really understand what's going on because they were never taught this. So take this moment to really get yourselves ahead of the game, all right? I'm gonna do 2 examples here. Something unique happens in the second example that I hope doesn't throw you for a loop too much, but it's also the exact reason why this method gets so confusing for a lot of people, is what's going to happen in that second example. So follow along. We're going to do 2 examples here real quick of this factor by grouping stuff. And then later on today, I'm going to upload a video where I go through just as many of those odd problems as I possibly can. I haven't done them yet. I don't even have an answer key for it. I'm just going to look at them and I'm going to go through, and I'm going to upload a huge video of just me doing these kind of problems so that you can see kind of what goes on up here and how you kind of solve them. So without further ado, these 2 problems do happen to be 2 of the ones that are on the assigned problems for you. So you can try to pick them out. I'm not going to tell you which ones they are. The first one I want to look at is 14b squared plus 142b plus 144. Now, at first glance, always look for a GCF. That's how we've always done these factoring things. You always want to find that GCF first, and in this case, we do have one. Our GCF here is just 2. If you're curious how you figure that out, make your factoring trees of each one, and you'll see that they only have a 2 in common on each one. Or you can use your calculator to figure out a GCF as well. I don't want to get into the nitty-gritty of that. We've done GCFs before. So take the GCF out. We get 2 out front, and then what's left over? Well, we get 7b squared plus 71b plus 72. And what you might notice here is this ain't 1. It's a 7. It's also not a perfect square, and neither is this. So we can't use the method we used before, and we can't use any of our special case methods because those needed the perfect squares. So we have to do something different here. What we're going to do also works when this is 1. It's just when this is 1, you don't multiply the 2 because you just get the same thing as over here, and it kind of just falls back on the method that we learned before. So what we're going to do to use this grouping thing is we're going to take this coefficient here, and we're going to take this coefficient here. We're going to multiply them together. So 7 times 72. And when we do that, we will get 504. Now, this 504 that I got when I multiplied those two coefficients together, that's the thing that I want to get all these different factors of. So, for example, 1 and 504, and there are a ton for this one, so I'm just going to write them down very quickly. 1 and 504, 2 and 252, 3, 168, 4 times 126, 6 times 84, 7 times 72, 8 times 63, 9 times 56, 12 times 42, 14 times 36, 18 times 28, and I'm probably about to go off the screen, or I already am, that's fine. And 21 times 24. Let's see what I can do about that real quick. Better. So here are all my factors that could give me the 504. Hope that you don't have a number that's that big with this many factors that go into it. They won't all be this big. This just happened to be one that has this many. And what we want to do is we want to figure out which one of those sets of factors can make this one in the middle. It's pretty similar to how we did things before, right? So what we're going to do is look through and figure out which set gives me a 71. It looks like right here, the 8 and 63. 63 plus 8 is 71. Here's where things get different. This is why we call this factoring by grouping. I can rewrite this number 71. I could write 71 as 8 plus 63. So that's what I'm going to do. For my next step here, I'm going to rewrite my GCF out front, my 7b squared. Those things didn't change. But now instead of writing 71b, I'm going to write the two things that can make it from my factors that I just found, 8 and 63. So plus 8b and plus 63b. That's what I just split this 71 into. And then I still have my plus 72 that I had at the end. Here's why we call it factoring by grouping. I'm going to group together the set of factors on the left and the set of factors on the right. So I'm going to add another set of parentheses, one right here. I grouped those two together. And now after this plus sign, I'm going to group these two together. And from each of these two groups, I'm going to look for another GCF. I'm going to try to factor each of these things. So let's see. In my first grouping here, do I have a GCF? Well, not a number, but I do have the variable in common. These things both have the letter B. So in my next line, I still have my 2 out front. That doesn't change. I still have my big set of parentheses. And now from here, I take a B out. So B times 7b plus 8. 7b plus 8. Because I took one of the b's out. Over here, I've got my plus sign. Do I have a GCF within this small group? Well, yes, I do. 63 and 72, those things both have 9 in common as a factor. So I can take a 9 out. So plus 9 times 63 divided by 9 is 7b, and 72 divided by 9 is 8. Close the parentheses off at the end. Now, if you've done this right up to this point, you should see something in common between these two things now. Do you see it? They both have this 7b plus 8 term. So I can once again take the GCF out, but this is a really weird GCF. This GCF is an entire expression. Both of these two terms have 7b plus 8 in common. So I take that out, and that'll leave me with a b here and a 9 here. So take a look at what this looks like. My 2 of my original GCF stays. And now I take this GCF out, 7b plus 8 comes out. Keep it in its parentheses. And now these two things that I left behind, they make my second parentheses. So b plus 9. B plus 9. And this is how it factors. Now, it's certainly not something that will just come to your brain for how to do this, but this is the method. This is how you'll do it each and every time when you get this case where it's not a perfect square and it's not 1. So basically, we're trying to figure out when you multiply these two endings, or these two ends, the one here, the A and the C terms, when you multiply them together, figure out your factors, which of those factors can make the term in the middle, use those factors to split it. Group the two sets, pull out GCFs from both, and you should see the same thing start to appear that you can then pull out again. It's a lot of work. I don't expect this to get done very quickly. This is the hardest thing that I'll have given you all year, quite frankly. Honestly, this is the hardest thing that I'll have given you all year. Are these kind of problems going to appear on the test that we're going to take at the end? I think I'll throw one of them up there. We're going to have one where we'll have to do this, but I'm not going to make it one that gives you like a million of these factors. I'll try to use some primes that'll make it only prime factors, okay? So let's do one more, the one that's going to kind of throw you for a loop here because something weird happens in it. Get this all erased. And we'll go through the same set of steps. So this next problem I want to look at, also one of the evens that I assigned you, is 25x cubed minus 215x squared plus 280x. All right, let's fly through this. So again, start things off, find your GCF if there is one. In this case, we do have one, it's 5x. Take that 5x out front, and it'll leave you with 5x squared minus 43x plus 56. This isn't 1. It's also not a perfect square. So if we're going to factor this, we need to try to factor it by grouping. So I'm going to take this 5, I'm going to take this 56, I'm going to multiply them together. And by the way, guys, in all of these that you do, we should end up with this kind of form where it's something squared, something else, and then nothing. Or backwards, nothing, then like an x, and then something squared. It's got to still have this form. Even if that meant adding another variable, like y, and then y squared. As long as it's kind of going from top to bottom, and then bottom to top, something like that, it works. And by bottom to top and top to bottom, I meant the exponents here. Squared, 1, 0. 0, 1, squared. So we need to have things still in this form for us to factor them. Make sure you use that to figure out if you forgot something in your GCF or not. I see a lot of people forget the variable part of their GCF. Don't forget it. 5 times 56. What do I get when I take 5 times 56? 280. I want the factors of 280. So 1 and 280, 2 and 140, 4 and 70, 5 and 56, 7 and 40, 8 and 35, 10 and 28, and 14 and 20. If you don't know how to come up with those, just take the number 280 and divide it by like your just number line and see if you get a whole number. So for example, you do 280 divided by 2, you get 140. Do 280 divided by 3, you get a decimal, so don't use that one. 280 divided by 4, you get 70. 280 divided by 5, 56. 280 divided by 6, you get a decimal, don't use that one. You could just keep working your way down the line until you get far enough. Now, of these numbers, which ones can I use to make a negative 43? Negative 43 looks like it's going to come from the 8 and 35. And for me to make a negative 43, both of these have to be negative. And that kind of makes sense because we still know that a plus sign here at the end means my two binomials should both have minus signs in them. just like we learned before. So -8, -35. Here's where that different part comes in. 5x squared, nothing changed there. I'm going to replace this with those two. So -8x and -35x. I need that x on each one. Plus 56. Now we start grouping. Again, we're going to group the first two together. And we're going to group these last two together, but we have this minus sign here. Here's how I want you to handle this. And this is the reason for all the mistakes, especially even into Mr. Malik's class. I've talked to him before. This causes a lot of mistakes. I'm going to spread this out just a little bit here. The -35x plus 56. When you see a negative on this next one, what I'd like you to do is slap a positive right before it, and then put your grouping parentheses so that you're including that negative inside those parentheses. Let's find our GCFs. So 5x stays out here. From the first one, looks like they've only got an x in common. So x, and then I'll have a 5x minus 8. For the second one, what's the GCF between -35x and 56? Here's the kicker. When you see this negative out front, take the negative with it as a GCF. So my GCF here is going to be negative, and it looks like 7 goes into both of these, and that's the biggest number. So I want to take out a -7 as the GCF from this. Hardest thing in the world for you guys to realize, that you have to take a negative out. When I take the -7 out, that'll leave behind a positive 5x, because -35 divided by -7 is positive 5. And 56 divided by -7 is a -8. And now you see that it's just what we wanted. I have this 5x minus 8 term, and I have this other 5x minus 8 term. So let's take those together. 5x minus 8. And then what does that leave behind? Well, it leaves behind an x and a -7. So we get our final answer, 5x times the quantity 5x minus 8 times the quantity x minus 7. This is tough. Tune into Zoom. I'll go over any of the problems that you need to. You could say, hey, Mr. Scott, I'm having trouble with number 13. Well, not number 13, that's not. I'm having trouble with number 16. Can you help me with it? Boom, we'll go through it right here, step by step. Okay? You've got all week to do this worksheet, including the weekend. I think I have this set to be due by like Sunday night, something like that. Do not put this one off. I promise you. You do not want to put this one off. Do a little bit each day. Okay? Take your time. Email me any questions or ask any on Zoom. Thanks, guys. Have a nice week, and we'll keep in touch.